All right, last one on 4.3, which is number 15. This is data on the rate of return of, this is Standard & Poor's 500, called S&P's 500, for their, on their stocks. And then we've got the rate of return of GE stock. And we're going to compare the two and see if there's any sort of association between the two from 1996 all the way up to 2010. And then we've got a bunch of questions that we're going to ask on these. So we want to draw a scatter diagram of the data treating the rate of return of the S&P 500 as the explanatory variable. So we want to make a scatter plot that I'm actually going to draw. Here's our data. I'm going to draw it down here so we can have our have it next to the questions. So it's going to look something like this. That's going to have the rate of return. Now that's the interest rate of S&P as our explanatory, and the rate of return for GE here. Now this is a percentage rate, so we're looking at, for example, 20.3% and 40% on their stocks, for example, 31, 51%. Then we come down to here and we lose 10% and we lost 6%. So it's not always as great as it sounds. Up 9%, up 20% on the stocks and so forth. So that's kind of what we're looking at here. So we're going to go ahead and make a scatter diagram. So we want to put the data in our calculator. And I already did that ahead of time. So if I turn it on. And here's all the data. There's 15 years worth. I put the data in. So if we want to make a scatter plot, we go to stat plot. I'm going to turn it on, and I want to go to the scatter plot, which is that first one. My X list is L1. Y list is L2, and I'm going to go zoom fit. I'm not sure why my zoom is not coming up. Oh, hit the wrong button there. Back to here, calculator. Okay, so let me go back to here. Not sure what's happening. So scatter plot, X list, L1, enter, zoom. Not sure why that menu's coming up. Because when I push zoom, let's quit. Because quit's always a good thing to do when you're in trouble. Alright, go to zoom. At least on the calculator it is. So we're going to go to zoom, stat, graph. So that's what it looks like, and I quickly realized, oh boy, I'm going to need some negatives on here. So fortunately I can extend my graph and make it look like this. Now I don't have a scale on here, so I'm going to look at trace. Now unfortunately when I do trace, it puts the data in the order that it was put in my calculator. So here's 0.2 and 0.4. Looks like it's here. Well, actually what I'm going to go ahead and do is, once I start writing this down, my calculator's going to go away. So it's going to look sort of like this. And then it comes up, hits here. And when we're sketching it, we're really just kind of trying to get a general trend of what this looks like. A little bit of a space. Then it jumps up here. There's a couple up here. And then one here. Okay. So we're looking at something sort of like that. Okay, mine looks maybe, the actual data looks maybe a little bit more linear than what mine does. These are probably a little bit higher, so maybe I should move these up here. Get rid of these guys, so maybe it's more something like that. Okay, so we're just trying to sketch it. Now I want to put a scale on here. So this is roughly 0.2 and 0.4. So that's going to help me out with my scale. 0.1, of course 0. And let's do maybe a couple more here. So trace, I'm going to kind of go, oops. There's 0.3 is out here, which makes sense. I'm just kind of following these along. I want to get some of these negatives. So there's negative 0.1. It's about right here. And hopefully my marks are pretty close to being consistent. Negative 0.2. And there we go. So we'll come down here to negative 0.4 and look at that. Okay, so here's my scatter diagram. Determine the correlation coefficient. Now I'm looking ahead. I want to find the correlation coefficient. Is there a linear relation? Find the least squares regression line. Predict it if it's 10%, and so forth. So question then is, does it look roughly linear? And I'm going to say, yeah, it's probably not that strong because it looks like it's a little bit wavy, but overall it's kind of a linear trend. So let's go ahead and find the regression line. Stat, calc, one variable, or linear regression, L1 and L2, down to calculate. And so there's my regression line. So it's going to be y hat equals, it's ax plus b. So here it's going to be 1.40 minus 0.001. And that actually matches up with my line pretty nicely. Just remembering x is the rate of return for S&P, y is the return for GE, and R is 0.88. So reasonably strong, not 0.9 or better, so not super strong, but not bad. So I've got yes linear, there's my equation, predict the rate of turn if S&P is 10%. So come down here, leave that up there. So if S&P is 10%, which is 0.10, then I would predict the return for GE to be 1.40 times 0.10, because everything's in decimals, minus 0.001. And if I do that, I'm going to do it on my calculator on the side. 1.4 times 0.10 minus 0.001, and I get 0.139. So that's how much I would expect it to be, or 13.9%. So if the rate of return on S&P is 10%, then that's what I expect on GE. If the actual return, so this is my predicted, if the actual was 13.2%, was GE's performance above or below what was predicted? Now they say, we've talked about this before here, below the average on all years. Well, that's really not, we don't know what all years was. We know what the predicted value is. So the actual was below what was predicted. Okay, below the predicted value. Interpret the slope, so that'd be G. The slope is 1.40 over 1. What? Remember, it's delta y over delta x. Change of y over change of x is our slope. So that would be percent, or the rate of GE stocks. Rate of return GE. Rate of return S&P. So, on average, for each increase of 1%. Ooh, we got to be careful how we're talking about this here. For each increase, in terms of what are we talking about here? Do we need to write this in percentages, or what are we referring to here? All right, so we're talking about, sorry about that, I had to take a pause there. So on average, for each increase of, if we're going to call these percents, for each increase of 1% on S&P rate of return, that corresponds to an increase of 1.4% for GE. Now if I convert these to decimals, then it'd be 0.01 and 0.014. So for each increase of 1% of rate of return for S&P, there is an increase of 1.4% of GE rate of return. Okay, does that make sense? Okay, so for every increase of 1% of S&P, there's an increase of 1.4 for the rate of return of GE. Okay. All right. And H, interpret the y-intercept. The y-intercept is that guy right there. Well, that's when x is 0. So y hat is 1.40 times x minus 0.001. So if we have is that meaningful, I guess is what we want to know. So if x is 0, that means if there's a 0 rate of return for S&P, does this make sense? Can there be a negative 0.1% rate of return for GE? Yeah, that's reasonable. Sometimes negatives don't make sense, but that's reasonable. And notice that's right in the middle of our data set too. And that's okay. So that's reasonable. Yes, it's reasonable. In the middle of the data set. And lastly, what proportion of the variability in GE's rate of return can be explained or attributed by the variability of the rate of return in S&P? Where in the world did that number come from? Well, that's our R squared, which is 0.88 squared, because remember that was R. I think I wrote it down up here somewhere. Yeah. So 0.88 squared is going to be 78.782, which is 78.2%. All right, there we go. That is it.